Good morning. Today we will see AM voltage distribution, AM power distribution, that is amplitude modulation, voltage distribution, amplitude modulation, power distribution. And in the previous class we have seen that AM DSB FC, that is amplitude modulation, double sideband full carrier, and that equation is given by VAM of t is equal to VC sine omega CT plus MAVC by 2 cos omega c minus omega m t minus MAVC by 2 cos omega c plus omega m t, and this is said to be AM voltage distribution, whereas this is our full carrier, and here this represents lower sideband and this represents upper sideband, because here we have FC minus FM, that is carrier frequency minus our message frequency. Here it is FC plus FM, that is our carrier frequency plus message frequency, and that is why it is called as lower sideband, this is called as upper sideband. And we know this is carrier because unmodulated carrier, this is what we have seen yesterday, and this is said to be AM voltage distribution equation. Now let us move on to the AM power distribution, and we know if it is AM DSB FC, it contains all the upper sideband, lower sideband and total power, isn't it? The carrier power, that is, we know the total power is given by carrier power because here we have carrier signal, plus it contains lower sideband power, plus it contains upper sideband power because it is AM DSB FC, that is amplitude modulation double sideband full carrier. So it has two sidebands and full carrier. So the total power will be given by the summation of these three powers. So we can write this as which is equal to VC square by R plus V square, this is lower sideband by R, plus this is upper sideband by R, and this every powers are represented in root mean square, that is RMS value. Therefore, we can write this carrier power. Now let us find the carrier power first. We have to find carrier power, lower sideband, upper sideband power, then only it is possible to substitute in this total power. Now let us find what is carrier power, PC. So what is carrier power? It is given as PC, which is equal to VC square by R. So here we have VC square by R. Since it is RMS value, already we have said that is in the RMS root mean square value, so that we can write 0.707 VC whole square by R, or we can write this as VC by root 2, because since it is RMS value, we know that it is VC by root 2 the whole square. This value we have mentioned here is 0.707, or we can write this as VC by root 2. If it is represented in RMS value, so we have to represent only by using 1 by root 2 divided by R. Therefore we can write which is equal to VC square by 2R. This is our carrier power. So carrier power is given by VC square by 2R. Now what we have to find? So we have found this carrier power. Now we have to find this upper sideband, lower sideband powers. Now what is the upper sideband and lower sideband power? That is PUSB. So now what we are finding is sideband powers, that is PSB, the sideband. So sideband means upper sideband and lower sideband. So it will be equal to P, lower sideband, which is equal to, here we have again 0.707 B sidebands, total sideband the whole square divided by R. Therefore we can write this as which is equal to, but we know that V sideband which is equal to MAVC by 2. Already we have written in the spectrum diagram. I hope you remember this. This is our lower sideband, this is our upper sideband, this is our carrier. Here we have MAVC by 2, and here we have VC, and here we have MAVC by 2. I hope you remember this. So from this we have written here VC. Since it is carrier, we have written VC. But now here we have sidebands. So what is present in the amplitude? That is MAVC by 2. So we have to represent that MAVC by 2 here. Therefore we can write this as MAVC by root 2 because it is RMS value. So MAVC by 2 the whole divided by root 2 the whole square divided by R. Therefore we can write this as which is equal to MA square VC square divided by 8R. This is our lower sideband, upper sideband power. Now we can write this as which is equal to MA square VC square, or we can write this as P upper sideband which is equal to P lower sideband which is equal to VMA square by 4 into VC square divided by 2R. Now what is this VC square by 2R? We know that VC square by 2R is equal to PC. Now we can replace this as P upper sideband P lower sideband which is equal to MA square by 4 into PC. So this is our sideband powers. Now what we found, that is carrier power and sideband power. Now what we have to substitute in the total power. Now what is total power? So total power PT which is equal to, we know that carrier power plus upper sideband power plus lower sideband power. Now what is carrier power? Let us refer here. What is carrier power? VC square by 2R. Therefore it is equal to VC square by 2R plus what is upper sideband power? So just now we have written upper sideband power is equal to MA square by 4 into PC. That is MA square by 4 into PC plus MA square by 4 into PC. And now we know this is PC carrier power plus here we have MA square by 4 PC plus MA square by 4 PC. Now let us take this PC as common. So PC 1 plus MA square by 4 plus MA square by 4. Therefore we can write this as which is equal to PC into 1 plus this MA square by 4 plus MA square by 4 will become MA square by 2. Therefore our total power PT is equal to PC into 1 plus MA square by 2. This is how we have to find this total power. Now let us draw the spectrum diagram. This is our power spectrum diagram. This is lower sideband power, this is carrier power, and this is our upper sideband power. This is power in watts, and here we have upper sideband. This is power upper sideband. This is power lower sideband. This is our carrier power. Now here we have P lower sideband which is equal to MA square by 4 into PC, and here it is P upper sideband which is equal to MA square by 4 into PC, and here we have PC, that is carrier power, which is equal to VC square by 2R. So here we have VC square by 2R. So that is what we are going to mention here. And here it is MA square by 4 PC. MA square by 4 PC. MA square by 4 PC. Lower sideband, upper sideband. This is called as power spectrum of AM. This is called as power spectrum of AM wave. That's it. Now let us do current calculation. So what we did is voltage distribution, power distribution. Now what we are going to do is we are going to calculate the current. This is current calculation for AM DSB FC. We know that PT is equal to PC into PT is equal to PC into 1 plus MA square by 2. Now what is P? P is equal to I square R. This we know very well. And what will be PT? That will be equal to IT square into R. And therefore we can write what is PC? PC will be is equal to IC square into R. If you are finding this carrier power, then we have to mention IC square into R. What is this PT? Total transmitted power. What is PC? This is carrier power. Now what is IT? That is total transmitted current. What is IC? That is carrier current. And what is R? This is the antenna resistance. Now we have to find PT by PC. PT by PC. So from this we can write PT by PC, which is equal to, we can write IT square R by IC square R. Therefore we can write this as IT by IC the whole square. So we can write this as which is equal to 1 plus MA square by 2. This IT by IC the whole square is equal to 1 plus MA square by 2. Or if you want to find from this, we can write anything. That is, we can find IT by IC, which will be equal to square root of, or we can write I total. So we can write I total will be is equal to IC into square root of 1 plus MA square by 2. So this is how we have to find the total current for AM DSB FC. So just now what we found is AM voltage distribution, AM power distribution, and this is how we have to calculate current for AM DSB FC, that is double sideband full carrier. Now the final thing is we have to find the transmission efficiency. What we have to find? That is transmission efficiency, that is eta. Transmission efficiency for AM DSB FC, that is double sideband full carrier. Now we know that the transmission efficiency is given by power in the sideband. This is power in sideband, the whole divided by total power into 100. Now what are the sideband power? That is P lower sideband power plus P upper sideband power divided by we have total power into 100. Now what is lower sideband power? So what is lower sideband power? That is MA square, that MA square by 4 into PC. So we can write this as MA square by 4 into PC plus MA square by 4 into PC divided by what is our total power? So our total power is PC into 1 plus MA square by 2. That is PC into 1 plus MA square by 2 into 100. Now we can write, which is equal to, here we have MA square by 4, MA square by 4 PC. So we can write this as MA square by 2 PC, because we have added 1 by 4 plus 1 by 2 will be 1 by 4 will become 1 by 2, that is 1 by 2 MA square PC divided by PC into 1 plus MA square by 2. Therefore we can write this as this PC gets cancelled. So we can write this as, which is equal to MA square by 2 the whole divided by, now we can write this as, take this common, 2 plus MA square by 2. Therefore we can write this as, which is equal to MA square by 2 plus MA square into 100. So into 100, here we have into 100. Therefore which is equal to, the percentage efficiency will be is equal to MA square by 2 plus MA square into 100. This is the transmission efficiency for AM DSB FC, that is double sideband full carrier. Now if we have critical modulation, that is if we have MA is equal to 1, let us assume that if MA is equal to 1, so what happens if MA is equal to 1? Then the percentage efficiency will be equal to 1 by 3, that is 1 by 3 into 100. Therefore we will have only 33.3%. Here we have MA by 2 plus MA, that is MA will be equal to, therefore percentage efficiency will be is equal to 1 divided by 2 plus 1. So this will be 1 by 3. So this will be 1 by 3. Therefore we will get percentage efficiency will be equal to 33.3%. So if you use AM DSB FC, this is for AM DSB FC, that is amplitude modulation double sideband full carrier. So if you use this AM DSB FC, what happens? Only 33.3% of energy is used, and the remaining power, every power are wasted. So that is why we are going to suppress the carrier and suppress the sideband. So if we transmit this double sideband full carrier, now what happens? We are using effectively only this 33.3%. And what happens to the other power? So every power are wasted by the carrier and by this sidebands, because these two sidebands are going to transmit only the same information. So no need to transmit that same information twice. So what we are going to do is, we are going to suppress one of the sideband, and also we are going to suppress the carrier, and that is the next technique, which is called as AM SSB, single sideband suppressed carrier, AM DSB SC, AM, that is amplitude modulation double sideband suppressed carrier. Now let us see this in the next video. Thank you.